of fuel consumption. So it's very important that we recognize that it said rate. So right away, okay, I'm thinking, oh, it's going to work just like velocity and distance, right? Okay, the rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable, okay, and strictly increasing function. If they're telling me that, there's probably some place that's going to be useful, okay? Twice differentiable and strictly increasing function. Okay, the graph of R and a table of selected values of R for the time interval from 0 to 90 are given. Okay, recorded for an airplane flight is twice differentiable. So it looks to me like if this is a rate of fuel consumption, that looks like that's the first derivative, but let's see what's going on here. Use the data from the table to approximate R prime of 45. Show the computations that lead to your answer. Indicate units of measure. Okay, so use the table to approximate. What do you think? Yeah, so we're going to use the table to find the slope. So I'm going to work here between 40 and 50. That would be a good approximation, all right? So we're going to say right in here, we're going to do R prime of 45 is approximately R of 50 minus R of 40 over 50 minus 40. Okay, it's a slope formula. We're approximating on as small an interval as possible. Okay, this type of question is designed to test your understanding of what the derivative is, right? The derivative is the instantaneous rate of change, which means we want to take as small an interval as possible for that average rate of change. The smallest possible interval we can get is between 40 and 50 with the known information that we have. All right. So this is a calculator section. So you could actually just put your answer directly from here. But I'll go ahead and write it out for you. 55 minus 40 over 10. So that's going to be 15 over 10. So that, did I make a mistake?
No.
Okay. So R prime of 45 is approximately 1.5, or you could leave it as 3 over 2. And then it says indicate units of measurement. Because on top we have gallons per minute, and on the bottom we have minutes. So it's going to be just gallons. Okay. Right, because on top we have gallons per minute. On the bottom we have minutes. So that'll be gallons per minute times minute over 1. So it's just gallons. Okay. So now that I think I have an answer, I'm going to double check to make sure I answered the question they asked. Okay. Did I find the approximation? Yes. And I wrote approximate. Show the computations. I did that. And then indicate the units of measure. So I'm good. Okay. So that was a pretty simple one. Okay. The rate of fuel consumption is increasing fastest at t equals 45 minutes. Okay. Remember, R is referring to the rate of fuel consumption. So R of t is increasing fastest. What is the value of R double prime of 45? Explain your reasoning. Yes.
Would it be 0? Because if that's where it's fastest, increasing, that's the maximum.
Okay. Yeah, Grace?
Is it because R prime of 45 is a constant? Because if you take the double prime of it, then or double derivative, then it would be like a 0.
Okay, let's think. It says that it is twice differentiable, right? So, and it's always increasing, right? So since it's always increasing, R prime at 45 must be greater than 0, right? And then R double prime of 45, what do we know about that? It's greater than 0. Wait a minute. Wait. Right. So then this is equal to 0, right? Is that what we're saying? Okay, so we have increasing, which means, okay, how do we explain this? I'm trying to think of the way, I don't know why I just got all tangled up.
Is it because it says the increasing fastest, which is a maximum, so that way after that it slows down when you're thinking of like slopes?
Okay,
That's how I thought of it.
okay, all right. So,
And then if you're a maximum or a minimum, your R double prime would be 0 because the tangent.
okay. Let's, you're both saying the same thing. It's just a matter of how we want to say it, right? R prime of 45 is greater than 0, right? And we know that R of t is always increasing, right? And we're going to say that R double prime of 45. What did we say that was going to be equal to? 0, right? Because what? Yes, because it is a maximum. We're going to say since this is where the fastest rate of increase is, right? How's that sound? Good. And that'll do it. Okay. Okay. Letter C. Everybody understand that one?
Yes.
Okay. All right. So, in my opinion, bless you, C is easier than B. Also, because B, you're getting points for an explanation, that's always scary because you never know what they're actually wanting. Like, you might completely understand it like we do, yet we might not use the phrases they want in the explanation, and that's so annoying. But since B relies really on the explanation to get the points, I want to make sure I try and at least do another one to get more points on this, okay? So looking at C, approximate the value. Well, left Riemann sums. As soon as I saw that, I'm like, yes, we can do this, right? We know left Riemann sums. 5 subintervals indicated by the data table. Okay, so let's make our intervals. Left Riemann sum. So let's see. We're gonna. There's 1, 2, 3, 4, 5. There's my 5 rectangles. Okay. So we're looking at, just read the question again because I get excited when I see something I know, right? Is the numerical approximation less than the actual integral? Okay, so let's see if we can get some space down here. So we're going to write that the integral from 0 to 90 of R of t dt is approximately, right? Now we're going to do the work. Okay, so we're looking at the first one is going from 0 to 30. Okay, something might be easier to look at it to make your rectangles on the graph here. 0 to 30, and then let's see, 30 to 40. It looks like it is easier to do it on the graph. 40 to 50. 50 to 70, and then 70 to 90. So I think it's definitely easier to look at it on the graph. Okay? Yes, sir.
If that would be on the test, would be withdrawn.
Absolutely. Yeah. Ben?
So for like free response questions, since there's like 1 point for each, what if we got like a part of one of them wrong? but we
So
got
it's
the rest
usually
right?
not 1 point for each. So that's the 9 points total broken up between these 4 parts. Usually the first couple have less points because they're easier. Okay. But so let's say that part C might be worth 3 points. Well, one of the points might simply be by knowing that the approximation is the left integral. So setting it up basically. All right. So
you can get like some stuff wrong, but still get like a point because you got like the math right.
Yes, as long as there's nothing that is conceptually incorrect. All right. So, like looking at this. So when I write, I'm going to write my formula out. So this is going to be right left Riemann sum. So it's 0 times the width, which is 30, plus the next rectangle is. Oops, did I do that right? I did that wrong. Yeah, I did that wrong. Yep. 20. Sorry. 20 times 30. And then we've got 30 times the width, which is 10, plus 40 times the width, which is 10, plus, let's see, 60 times the width of 20. 1, 2, 3, 4, plus this one's going up to 970 rather, times a width of 20. Okay. Did I make a mistake?
It's 65. Would it be 65 instead of 20? Or 70? Yeah, and 50.
20 times
It
30,
would be 55 and
30 times 10, 40 times 10, 55,
55. and
65.
65.
Yeah.
Okay. So let's say you have this problem. Part C would probably be worth 3 points. They're probably going to give you a point just for setting that up. Okay. So then you're probably going to get another point for writing getting the correct answer. So what did we get there? What is it? 3,700. Okay. Okay, now what's the unit? Gallons, yes. So you're probably going to get a point for setting this up and for writing approximately. You're going to get a point for the answer, and you're going to get a point for having the correct unit. Okay? Unfortunately, if you do something incorrect there, like for instance, and they're not consistent with this. Let's say that you put an equal sign there. They might take a point off for that because they said approximate it. If they said determine the integral, they may not take a point off, but they said approximate, so they probably would take a point off. Okay?
They know what I mean, right?
Oh, I'm sorry, there's another part. Is this numerical approximation less than the value?
It's less than because the rectangles are underneath the curves.
Okay, so this is where, okay, listen. This is where we have to use the terminology they want. We're going to say it's less than, right? We're going to say that this is less than the actual integral because r of t is always increasing and concave down. Okay. Oh, it's not always concave down, so don't say that. Just say it's always increasing. We're going to look at it again just to see. Okay, what else do we know? No, that should be good.
So your justification is just the increasing?
Mm-hmm. Yep. Okay.
How would you justify the chapters in
Same type of thing. We'll go over those. There is justification for all those based on left or right 3 months on. Good. Yep. Okay. Part D, from 0 to 90 minutes, explain the meaning. Okay, from 0 to B, if B is between 0 and 90 in terms of the fuel consumption of the plane. Okay, if R of T represents the rate of fuel consumption, then what does that integral represent?
The actual fuel consumed.
total fuel consumption.
Total, that's the word we want. Yes, okay. So I need to just give myself some space here. Let's see. So we're going to say 0 to B, R of T. We need to use that word total. Is the total fuel consumed.
You have to put in gallons, right? Because it says indicate units of measurement in both answers. Why is it the total?
That's what integration is. Integration's giving us a total of something. Okay? Consumed for the plane.
Over the time period, 0 to
We can say total gallons of fuel. How about that?
Yeah, I just put in parentheses, like after fuel.
Okay. So the integral is the total gallons of fuel consumed for the plane.
Over the time period, 0 to B.
Yes, between the time. Well, if we're going 0 to B, you can phrase it that way. That's okay. But I'm just going to say,
You also just do like
I'm going to say total consumed for the plane in B minutes because we're starting at 0. Okay. You could say between 0 and B. That's fine. Right? Okay, then the next part, explain the meaning of 1 over B times the integral. What is 1 over B times the integral?
it's the specific number of gallons per minute. Or like per time given, like something like that.
It's the average what?
Fuel used.
The average amount of fuel used. Yes. Okay. Okay. 1 over B times the integral blah, blah, blah is we could say the actual, or we could say explain the meaning of 1 over B. Yeah, no, that's fine. Is the average gallons of fuel consumed
If I say used to it, give me points off.
per minute. Okay. Again, this problem, because there's so many points for explanations, make sure that you focus your time on the calculations. Because again, we understand it. And all of these were pretty easy for a free response question. Okay. We understand all 4 parts of it, but chances are we're not going to get all the points because of the way they're so picky about things. Things to remember, okay? Consumed per minute, okay? Things to remember, okay? 1 over B is not the average rate, it's the average of value or the average amount, okay? Also, when we're talking about integration, we're talking about the total amount of something, okay? Integrating gives us the total amount.
Do you want us to turn this back into Google Classroom?
Yes, please. Okay. This one here where we're approximating the Riemann sum, that's great because that's probably going to give us a lot of points on that one. Yes. A and C
I thought it was easy.
I thought I did wrong.
Because it was such a
because it's so easy.
It was such a low number though.
Okay.
That's why.
Also, another thing to help you, these are usually set up to progress through the problem. Okay? And when they give us information like this, twice differentiable and always increasing, usually we're going to be using that somewhere in the problem. Okay? All right?
Would it have like changed anything if it didn't say it was twice differentiable, but asked like?
If it didn't say twice differentiable, then we do not know that R double prime even exists.
So would we say that?
Yeah.
Mm-hmm. If there's nothing indicating that it's twice differentiable. Okay. I'm going to let you spend the rest of the period starting on that test. Okay? So we don't have class Friday, right? Okay.
We only have 4 classes.
Except for Charlie.
And yeah, and solo.
Oh, yeah?
We only have 4 class periods.
You're just going to work on your test.
We only have 4 class periods though. Which one do you want me
I know. It's very stressful. I need you guys to come to those flex periods.
Which one do you want me adding to? The FRQ Lauren?
No, the original one.
Okay. Monday, Wednesday, Friday next week, and then we miss Monday because of AP Gov testing, and then we have the Wednesday